today in Programming with Objects, we're looking at methods and functions. I hope you're all well, and I spoke to all of you on Monday, and you actually preferred me just sort of doing the lecture this way so that you can actually read the slides as we sort of go along, rather than prancing like an idiot in front of a television, and you can't actually see the lecture slides. But anyway, I thought I'd sort of do this just now. Up until this particular point, we've more or less been putting nearly everything into the main procedure or the main function in C#, which quite clearly isn't workable, because you eventually have to, have different methods, different functions. So when I was sort of doing my software engineering degree, a function really returned something like an integer or a value or something like that. And a method didn't really return anything, so it was just sort of void and it performed some form of functionality. But anyway, this is really about compartmentalizing, decomposing, fragmenting code into sectional sort of workable components and constituents for efficiency, reuse, and demonstrably logical design. So you're really breaking down a problem. So it's a sort of top-down design, which is the decomposition of a system into smaller parts in order to comprehend its computational sort of subsystems. And I'm thrilled with that because I just thought of that definition in the car, apart from the top-down design part. That was taken from somewhere else, but the compartmentalizing, decomposing, fragmenting code into sectional workable components and constituents for efficiency, reuse, and demonstrable logical design. All me, baby. So quite happy with that. Right, so methods and functions today, and that's what the labs are about as well, and basically just giving you sort of practice with this, so it's your sort of basic bread and butter stuff. Okay, so this is going to be lecture 7. Methods are covered in the book in chapter 15, so that's all good. If you're not sort of reading the book, it does look as if Martin is producing nice summaries of the book chapters. So it would be quite good to have a look at them if you can't be bothered reading about it. But I would recommend that you do read it yourself, because it is the sort of way that you learn. Programming, as I've sort of said, it's a little bitty. So I would say you've got to read a book, you've got to do lots of practice, and there are many ways to sort of learn constituents of programming. And if you can read a book at the same time, brilliant. But Martin is going to do some summaries. So that's chapter 15, methods in the book, and that's the book that we've sort of been following this entire time, the C# player guide. Okay, so I'm sure that if you can't be bothered reading a chapter in a book, which by the way is pretty poor show, can't be bothered reading a book, then perhaps study is not for you. But Martin will get some nice summaries up, I'm sure. He's doing that anyway on the Aula system. Very sort of thankful for that. So up until this point, we've been using methods in C# for some time, even though we probably didn't really particularly know it. These are all methods which we have been calling to do tasks for us. Okay. So these are some examples of methods that we've in fact been using. So the console.writeLine, that is in fact a method, and that's outputting the score as well. And the console.readLine too. Okay, so that's you taking in the string, as we have been up until this point, and probably not even realizing that we're using methods, but we have been. But this is really about constructing your own methods. The ability to construct your own methods, the ability to construct your own functions, the ability to construct your own classes, and sort of realize the distinction between all of these. So by the end of this, you should be able to sort of say, right, okay, I want to write a function that's reusable for this particular purpose, and of course you get the sort of logical ones. What you have to be a bit sort of careful about, not careful, but C# and all programming languages have sort of existing functionality that's already there. So what you're not wanting to do is reinvent the wheel, so to speak. So if they've already got some form of implementation, you're probably not going to improve upon that. Now, one sort of example that springs to mind is the sort of set data structures that you have in C#, like lists, stacks, queues. Although it is good practice to sort of implement your own, once you become good at programming, do you really want to go through all of that nonsense to implement your own? Probably not, even though it would be easy for you to do so. So a method is a block of code that you can refer to by its identifier. So obviously it has a name. As we've sort of discussed in prior previous lectures, do give all of these things meaningful names so that you know exactly what you're calling, whether it's variable names or method names or class names, to make sure that you can actually sort of keep track of these things. Now, I know up until this point you're only sort of writing small programs, and that's all fair enough, but there will come a stage when you write a program that's so massive that you'll forget what the variables are actually all about if you don't name them well. So whenever you refer to a method, the block of code that is in the method is executed for you. So it lets you break a solution down into smaller parts. So decomposing the problem in a top-down sort of design sort of fashion in order for you to appropriately sort of break down the problem. So what we've sort of looked at in pseudocode before and flowcharts and things like that, if you can think about all of these sorts of problems logically, you can then come up with the methods or the functions in order to execute these things, and then all you're doing is really calling them at the appropriate time. Okay. So every program that we've previously encountered so far has consisted of one function, and that's the main function, and that's where everything else is really sort of called from. So fortunately, production of functions and methods allows you to break down a program when it becomes too complex simply to be contained in the main function, and of course it will. Presumably, some of you, if you've had no sort of programming experience before, would have been sort of thinking about that. How do you actually sort of get a more complex program to run simply from this one function? And of course, the answer is it can't really work. You've got to be able to create your own. So you've got to create new functions, accept values into a function via parameter passing. So we'll cover that. Return information via return values, so that would be a sort of function, and we'll show you how to do return values as well. You can work with global variables and constants. My phone just distracted me there. Working with global variables and constants. Overloading functions and inline functions don't really refer to, are not really relevant to C#. But they are perhaps about relevant to C++. Okay. So in C#, all subroutines are functions. Some return a value when they're actually calling code, and some do not. So some are void functions. So we'll sort of point that out to you at the appropriate stage. And the point of a function is to allow a section of code to be packaged, sort of encapsulated, so that it becomes a reusable part of that program. And it's all to do with efficiency, because essentially programmers are entirely lazy. And once they write a function for one particular thing, they don't want to write a function again. And it's just a case of calling that again and then again and again. So you'll have seen this prior to all of that sort of thing when you hit the dot operator in C# and you'll notice that a list of functions materializes before your eyes. So that's existing functionality that's already there. And it can be used by other programs as well. If you write a bunch of functions, then of course you can more or less just copy them straight in if they're generic, or you can import them in. And it allows the programmer to ignore forget how it actually works. So it's really abstraction. It's hiding the complexity of what's actually taking place once it's implemented and it's done. We'll discuss abstraction to a small extent as well. So functions and methods. A function is a piece of code that is called by name. It can be passed data to operate on, so parameters. Yeah, and can optionally return, so there is a return value. All data that is passed to a function is explicitly passed. Okay, And a method, these are sort of differences between the two. A method is a piece of code that is called by a name that's associated with an object. And in most respects, it's identical to a function except for two key differences. And a method is implicitly past the object on which it is called. And a method is able to operate on data that is contained within the class. Okay, so we'll cover classes at a later date. Remembering that an object is an instance of a class, okay, and the class definition, and the object is a sort of working sort of version of that particular data, for want of a better sort of description. So let's talk about our first method. This is me trying to sort of assimilate the previous lecturer's stuff with mine as well. So he had this sort of example which I've sort of kept. So this method is called do it. Do it. Yes. Emperor Palpatine, Senator Chancellor Palpatine. Do it. You know, kill him. Do it now. Sorry. The body just prints out a message, does not return the value, so it's void, and it does not work in anything, so there's no parameters associated with it. Okay. Handsome boy, isn't he? Okay, so here we go. You've got your do it function there, our first method, okay? And all it does is print out hello, and that's to show you the reusability of it. I should have put kill him, do it now, do it. Sorry, instead of the boring hello. So you have your main method there, and all it does there is it calls do it twice, and then sort of pauses the program. I think in 2019, Microsoft Visual Studio 2019, as we've discussed, we don't actually need that console.read key. But in previous versions, you would have had to use it. Okay, so do it is fine. And that is what you get there. And it's just hello, 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 hello. I've just come to say hello. Yes, so that is exactly it. It's not really particularly complex, but that's to demonstrate the reusability of methods there. Okay, so all you're doing there is calling that method twice. Do it, do it. And you kind of notice that when it's not really particularly well named, I'm not happy with it, but you kind of notice that you've got to have the brackets at the end, because when you're calling a function or a method, except in some cases, you've got to have that, otherwise it won't recognize it. Okay, excellent. Right, method header. So the header at the top of the method tells the compiler about the method. The type of value that the method in fact returns, so you notice that that's a void, so it doesn't return anything, and the items that it works on as well. So that is going to be the parameters that are passed into the brackets, and we're going to be looking at that at some stage. So console.writeLine hello, and that of course has a method in itself. So there we have it. Okay, that's the method header. Now the method body. It's really the block of code. Now, obviously, blocks of code can contain many statements. We've sort of seen that before. And when the block is finished, the method ends and the control returns to the caller. So in the sort of previous example, we've called do it from the main procedure or the main function, and therefore it will return straight to that. Okay, so that's the method body. Method parameters. You can give a method parameters if you want to pass some information into it, and you've been doing this all this time, possibly without knowing it. So you've been doing it with writeLine and convert.toInt32. For example, if you're passing in a particular string, I've always said that's passing in a parameter. However, not all methods need something to work on, and it really depends on what the method is being used for. Now, later on, we're going to look at things like sum, difference, product, and quotient to give you a sort of idea about how these functions are sort of called or can be called. And again, it's a bit of a design choice, whether they return anything, whether they actually perform that function within it, the body of the method or the function, yeah. And it really sort of depends how you're wanting to design it. But when it's done sort of efficiently, if you have sum, difference, product, quotient, and you have two sort of variables, integer variables, perhaps x and y, you can pass those variables into every single one of those and then see what the result is. And of course, you can call that in multiple different ways, different times. Okay. So here's a sort of example here. You've got the class marks that we sort of looked at. I think it was last week or something like that, when we were discussing arrays. We've got 10 integer variables held in an array. And then you've got your sort of class marks as x55. Yep. And then, okay, you're going through all of the items in that array. Are you going through each of the sort of segments in that array using the for loop? And then what you're doing is you're simply entering a value, and we've got the index as well. So for the right line there, you're actually putting in two parameters, really. You're putting in that string. Well, it's an entire string parameter, but you're sort of concatenating the strings together. One of those strings is, of course, in a variable, and you're saying plus the index. And then you'll notice that you're using another method to read in the array value as a string. You're then converting that array value as a string to an integer value using the convert dot to int32 and passing that in there as a variable as well. And then, of course, you're sort of doing what we did last week. Okay, so sort of example there. Once again, you can sort of put that into the coding window and see how that sort of works out. Okay. Okay, a method with a parameter, and once again, this was the last guy's slides, who has now sort of retired, and I don't really particularly care for these examples, but nevertheless, they're examples, and hopefully they sort of help you. This method has an identifier, which is called silly, which is bloody silly. I don't know why I keep it. It has passed a single integer parameter, as you can see in the curly brackets there. I wonder if I can actually run this. Ooh, let's see. So here, oh no, let's use a different color. Let's use red. Ooh, no, that's rubbish. Yellow. Ooh, yellow. No, that's just rubbish. Nonsense. Okay. There's a pen. But let's do red. Ooh, I'd never tried this before. So there's the integer. Ooh, yes, that's better. There's the integer variable there that you're passing in as a parameter. So that's excellent. And then, of course, you're just sort of printing that out and saying that I is plus I, whichever you sort of pass in there. Okay. Whatever you're wanting to do. And of course, you can call that multiple times and put in whatever you want. Okay, so here we have an example. This is calling silly. Oh, God. The call of silly must now include a parameter value for it to receive. Now, if you specify a method with a parameter and then you don't actually put a parameter in, it will give you a compiler error. So you now have to include a parameter value for it to receive. Must be an integer, so it's got to be the appropriate type, since that is what we've actually said, and that is what silly will expect. So in this particular case, in silly, you're putting in 101 and 500. Excellent. Okay, so basically that's just going to output 101 and 500. Okay, fair enough. Return values. A method can also return information to a caller. We've seen this before in the readline method. So essentially, you'll notice in the sort of previous slides, and I hope I have an example after this. For some bizarre reason, I cannot backtrack when I'm making these recordings because it would overwrite the recording in the previous slide, presumably. But anyway, you've been doing this with the readline method, and on the previous slide, you noticed that we had a value as a string, which then became a value converted to an integer. And you actually passed, well, the readline method just takes in a string, yeah? So that's fine. And then we've had to do that sort of conversion that I spoke of. So to tell the compiler this, we must identify the type of data the method will return. And the method must also contain a statement which returns the result as well. So here we have this. So this is a useful method, not really particularly silly, so great. So the method identifier is add, okay? So here it is here. You'll notice that it returns an integer, okay? So static int, so that's the value that it returns. In here, it then has two integer parameters, I and j, that go in there. Brilliant. And then, of course, you have the return statement, which is the two integers actually added together. So that returns this to this. Ooh, yes, I'm really rather enjoying this drawy stuff. I'm glad that people actually got me onto this. So thank you. Yeah, it's not bad. So it returns the result of the two integers added together. Good stuff. Okay, so the method type, up until now, all methods have really been void, which means they return nothing. Oaken Shield has weighed the value of your life and found it worth nothing. So it's returned absolutely nothing up until this point. And if it did return nothing, it would be void. But obviously, you wouldn't be using a return statement to return nothing. Okay, so it's just been void. Means the return nothing. If a method has a type, then the method must return a value of that particular type. Okay, so it's got to return this eventually, invariably, has to be an integer, returning a type. These are two integers added together, which will equal another integer. Yes, and then it will be returned to here. Ooh, love it. Fantastic. Okay, so the return keyword is how a method returns a value. Void methods don't need to return, as they don't return a value. So we're returning that to there, as sort of discussed. Brilliant. Okay, so calling add. So this is our main procedure, main method, main function. You notice that the main is void, so it doesn't return anything. I think in some cases, I've seen it in C++ before, where you can actually have an integer returned in the main, and that sort of can help assist to end the program as well. Never mind. So you've got an integer result, okay? So what you're doing here is you're declaring this particular variable here called integer result, which will be the addition of 2 plus 2 when you call this particular method and pass in these parameters, okay? So there's your method name, add, you're passing in the parameters 2 and 2, okay? And then you're just outputting result, which of course should be 4, yeah? So you've got to actually declare what that is, run through the method and return the values. Excellent, okay? So I'm happy with that. So here we have it. We're simply calling add once again. I reiterate, it's possibly best that I sort of do because it's important to get this into your mind. So we've got it returning an integer, okay? We'll worry about static later. That's the name of the method, add, fair enough. We're having the two parameters in the brackets, which are two integers, I and j, and then I gets added to j and is of course returning that there. Okay, fantabulous. Okay, so there's your main. Integer result equals 2 and 2. Okay, so that's the new variable. Then you're calling the method add, you're passing in the two parameters, and of course when the control flow happens here, I'm getting way too happy with this drawing stuff. So the main, it starts in the main, then the control flow comes here, it then calls that method, all right, okay, jumps to there, completes that, returns the value, and then goes straight back into the result section, okay? So control.writeLine result, and then console.writeLine result, so prints out the result. So that's great. And then, of course, that's exactly what you have pretty unimpressive. We knew it was all going to be the case. Okay, we've got a wee 4 there. Yes, great. So that's you calling add. That's the way the sort of flow of control happens in the program. Okay, bad calls. Let's have a look at this. What have we sort of meant here? So you've got an integer, r1 equals add. This won't compile. This is a sort of bad call as well, because I mean you're passing two integers, right? Into add integers, and that would quite clearly. This wasn't me that kind of came up with these slides, but that would quite clearly be a float. Yes, they all float down here, and you will too. They all float. With his Pennywise. They all float. Okay. You float. Okay, so that's a float, quite clearly, 2.0. And then, of course, the next one, which will not compile either, is because it's only got one parameter. Yeah? And it doesn't have two. The method is expecting two parameters. And of course, you need that. Okay. Now, here's another example of badness. So now we're saying that we're adding two integers together, because that's what add expects. And then in R1, we're expecting that to be a float, which will not be the case. Okay, so not great. I don't know if these will compile, but that certainly won't. It might do a sort of conversion for you there. Okay, add 2 and 2. That's fine in a sense, but I think that you've got to assign it to something, because that's all that it just simply returns a value to you. It won't print that out to the screen automatically. You've got to write the code for that. Okay, so if we get the parameters wrong, we'll get a compilation error. However, ignoring the result returned by a method does not cause an error sometimes. Okay, so you've got to be a wee bit careful there, and that's where breakpoints and everything sort of come into it, just to make sure. But yeah, that's a float, so that's icky. That's only one parameter here, which isn't right. That's expecting a float when you've passed in two integers, bad. And then you haven't got anything actually displaying the result. Okay, it will return the result perhaps, and it will be 4, but it's just there in Never Land. Okay, so variables as parameters. You can of course pass in variables as parameters, and that's a bit, more in terms of programming power and reusability. So you get int I equals 3, int j equals 2. So int the result equals add I and j, and that's absolutely 100% legal. So you can use variables as parameters to a method, and their value is passed into that method. So essentially I is 3, j is 2, and that would of course give you 5. Brilliant. And yeah, you're specifying the results and the type of the variable in that language. Good stuff. Okay, variable values as parameters. So you get int I, that's fine, because the value of q is passed into the method. The program would of course print 0. So be a bit sort of careful about things like that. So you get int q. That's an assignment. That's the value of q that's actually being passed in there. So that's 0, okay? It's being passed into 0 is being passed into changer. So you get int, that's the 0 there. So you get 0 equals 0 plus 1, okay? And then of course, there you go. So be a bit careful about what you actually pass into them in terms of you can use the value. Right, passing references to alter arguments. When you pass a variable to a function, what happens is it actually gets a copy of that variable. But the original variable argument within that particular function remains unchanged. So you're passing it to something else and you're passing it back, but the main one that you've actually passed in the first place, that's a copy that's being passed and not the real variable, so that remains unchanged. And sometimes that is the desirable result, and that's what you want, but sometimes it isn't. And if you want to change an argument variable inside a function, then you've got to achieve that through references. Now this will all be in your class test, which is multiple choice. Class test. I'm just trying to perfect my drawing with a mouse, which doesn't seem to be going particularly well. Okay, so let's have a look at this. Passing a parameter by value. Okay, so what we're doing here is we've got an integer, lives left equals 3. Okay, so you're printing out lives left. Then you're calling that, and what it does is it returns lives, increments that, okay? And that's absolutely fine. Then you'll notice that we're printing this out twice. So what will happen is you're printing out 3 lives left, okay? Then you're going through the formality of calling this. It will return that value. But once again, what you're doing here is you're printing out lives left. Even though you've called that here, it will not change this. So you're going to get 3 again. So basically, what you're going to get is 3 and 3, despite the fact that you think in your mind you've actually added or incremented to lives left by calling that particular method and function, okay? But here's where you've actually got to write the code to do that. If you're trying to increment that, lives left has got to equal add life, and then you're calling this method again, and then passing in lives left in order to get 4. Okay, so in this particular scenario, that doesn't change, that doesn't change. You will get that value, but of course, that value of 4, but you're only passing in a copy of that variable to that particular method at that point. You only change that when you use the method in conjunction with the variable. So this is what you get from that. You get 3, you'll get 3, and then you'll get 4 because you're actually changing that because you're sending in a copy. Okay, so that's passing by value. This is passing by reference, and I ruined the surprise. Oh no! Oh, the code, the window has actually come up. Anyway, never mind. Forget all of that. This is us passing by reference now. So what happens there is it gets the actual variable itself, and it changes that. Okay, I can't go back to sort of show you, but I've got another example coming up in the slides. So you get int lives left equals 3, okay? Then you're printing that out, which will be 3. Yep. And then you're passing that in as a reference, lives left. So you're passing in 3, but that is the same variable, and it's not a copy anymore. So you're actually changing that variable there, okay? And then you're going to get 4, and then you're doing it again, okay? Well, you're still passing it in. Lives left equals, you're doing it in a different sort of way, but just to show you the sort of variability of it. So you get 3, 4, 5. And there, when we print out lives left, fair enough. So just to reiterate, add life here, you're calling that. At that particular point, you're passing in 3. You are returning 4. Yep, because you're incrementing that, great, and then you're going back and then you're printing out 4. And then you're passing it in again, and you're passing in 4, yep. Ooh, it looks terrible now. And then it goes in there, and then it's printing out 5. So 3, 4, 5. 3, 4, and 5. Oh, I'm loving this drawing stuff. Yeah. Okay, here's a value and a reference example combined into one. So all we're doing here is we're adding 1. Now this particular example will be the exact example in your class test, and you'll be asked about the output that actually produces this particular line of code, not line of code, but this main method and these 2 methods actually produce, and what the output is in fact going to be. Now, it is exactly as we have just discussed. Okay, so we get int x equals 5, right? And this one, you're passing in the variable. Yep, so you're passing in 5. Then it's adding 1. Okay? And notice you don't have to call it X when you're actually passing it in here. So I've called it Y just for no reason whatsoever. I just need some caffeine. You baby. Okay, so you're passing in 5, but and although it's altering a copy of that variable, when you print it out again, here with the console.write line, this line here, you're in fact printing out 5 again. It's changed a copy, hasn't changed the actual variable itself. So you're going to get 5 and 5. Yeah, but in this one, add 1. You're passing that in as a reference. You're actually passing that variable in. So you're changing the variable then, and not a copy of the variable. So then, when you print this out again, you're going to get 6. Whee! So let's just see what happens here. You've got integer x equals or assigned to 5. You're printing out 5. You're then saying add 1, so you're going to this. That's doing its magic, and it will return the value of 6, which is fine. But then when it returns control to here, you'll print out the 5. That's fair enough. And then you're going to the next line, which is adding 1. But this is doing the reference version of it, okay? The reference version of that method. And you're actually passing in the variable itself. And then when you return to the control to the program, I'm sorry, it's starting to look like Spaghetti Junction because I'm becoming draw happy. Oh, good. Right, so then it'll actually print out 6 next time because it's changed that. So let's see. It will be 5, 5, 6. Yes! Fantastic. Okay. Now, one of the tricky things that I've actually put into the class test is that I've slightly messed with you a little bit in terms of the variable names for these methods. So it'll ask you what the output is going to be, and it'll change the numbers, but it'll of course change the letters as well. So it'll say y equals 5, y equals 6, that sort of thing, and it'll mess with you a little bit there. But remember that this is in fact the output to the screen, and they are all x's. So bear that in mind. That's my little tip for the day. Okay, so we're moving on. Method overloading is the same method name, but you can have a different parameter list. And the reason that the compiler can actually differentiate between them all is because of the parameter types within the list. But you can have the same method name. So here we have it here. You've got add, which takes 2 parameters, okay? And then you've got add, which takes 3. But you've also 3 integers. So here we've got 2 integers, 3 integers. It adds all of them. That's fine, fair enough. But you can also have an add that returns a double and takes 2 doubles as well. Yeah, and these are all named the same. And it's method overloading, this is called, and that's absolutely fine. And it differentiates between the type of parameters, yes, and the parameter list, and that's good. So in that one, the number and the type of parameters. So in that one, you get 2 parameters of type integer. You get 3 parameters of type integer, and then of course you've got 2 parameters of type double. Let's see if we can type double. Yep. Okay, good stuff. So loading. Methods in design. Methods are an important tool for a programmer in order to sort of reuse code, break down, decompose a problem, compartmentalize these things. And these are the sort of most important components you're reusing, and you're breaking down a problem into smaller chunks and decomposing it in order to think about it logically. Okay. Code reuse, programmers are very careful to do a minimum amount of work. If you're coding thousands and thousands of lines of code for a simple task, you're doing it incorrectly. And this means that they try to write as little code as possible. And if I know computer games development students, we're talking about that in every aspect of life, whether it's a dissertation or a program specification, they're trying to write as little as possible. And that's the same with code. And methods let them write code once and then use it all over the system. And it also makes the code easier to test and update, so code reusability, because once you've got a particular method working, you know it works, And then if something else goes wrong in your program, then you come to the realization this has been tested before. It's not that. It's something else. It's another method in the program. So breaking down a problem, very useful to break down a problem into a series of smaller ones. You can use the method headers to show what method works, what the method works on, and what it needs to return. So it's perfectly readable. You can also test each method individually, and that is just glorious. Yep. So method overloading, we sort of looked at that sort of thing before. But anyway, let's have a look at this. The main game loop. So we've got a sort of main game loop for a computer. We'll continue until the game over method returns true. Okay. Now you've got, this is obviously battleships or something. This wasn't my example, but you've got clear C, place the ships and display the C. And while the game is not over, you're getting the player move and they're making a particular move. Okay, so something obviously has to happen in here in order to make this value equal to false to exit the game. Okay, not really sure why that's method overloading as such. It doesn't seem to be, but yeah, it's just a sort of main game loop example. Right, these are my examples of functions, which I think are far, far better. So here we go, we've got some example functions here. So you get a static void function, which just simply says hello. Now you can call that at any point, and it's hello, hello, hello. But it's very, very limited, and it can only ever say hello, and that's it. That's the reusability factor. Now here, what we've got is passing in a name, yeah, still returning nothing, so it's void, but you're saying hi, so you can then pass in the name Thomas, perhaps. I can't write anymore. Thomas, and then what it'll do there is it will go into this line of code and it will type out hi plus the name that you've passed in as a string parameter. So that's glorious. So it's a wee bit more flexible and you can add information. This is even better because what sort of happens is, oh, this is enter your age. What's the name? That's not right. It shouldn't be quite right there. Oh, it is get age. Oh, right, sorry. I beg your pardon. What you're doing is you're entering in your name there, you're passing your name in as a parameter, so that's good. And then it's saying enter your age, Thomas, or whatever. And then you're actually entering that age, your age, okay? And I believe when I wrote this, I was 38, and I just turned 40 last Friday, so that's been pretty good. Been 40 for a week. Anyway, so you're then reading that, and then what we have to do is that passes that to that ages string. Okay, so that's a sort of variable that you defined age as string, and you're reading that in as a user input. And then, of course, you're having to convert that to an integer. So once again, integer age, and you're converting that here and passing this in as a parameter into there in order to perform the conversion. You're then returning that to there as an integer. So there you go, even better, gives you some flexibility, and that will give you, please enter your name, enter your age, Thomas, and then you enter that and everything's sort of hunky-dory. Now, when you're thinking of functions in a game context, a game is incredibly complicated, and you've got to think of all the sort of different things that happen within a game. So there are many, many things. So like load player data. How do you save the player data as well? Let's go for blue now because that's not showing up very well. Yay! Loading player data, saving the player data, updating the player status. How does that actually sort of occur? Fire, some form of blasting move. If you're moving the player, what happens if they die? A battle, calculating the experience, leveling up. So there are many, many things in a game's context to actually consider. Okay. So I mean, when you consider everything that's sort of happening on this screen, you've got updating the health. You've got sort of the battle system, even compartmentalizing Scorpion's punch, throwing that punch is difficult. You've got displaying everything on the screen. You've got the player move. You've got the decrease in health. You've got updating the time. You've got many things to actually update on that screen, and many things to compartmentalize. A lot of things are happening in that particular scene. Okay, so think about that in a games context. Right, obviously, C# allows you to write multiple functions. And they work like the functions in standard language, and they perform a task, return to the flow of the program, and your function should perform one job very well. And functions can be called from the main procedure or the main function, or other functions as well. But then you've got to have a wee sort of list. So I mean, if you have the main procedure here, then all the other sort of functions, we'll move back to red, all the other sort of functions that are called can be sort of formulated in a nice little boxy list as well. And then of course it can go utterly haywire with all these functions being called if you so desire. I'm loving the drawing. Okay, enough. Right, here's creating functions again. I've got a sort of instructions function here. So this is fairly straightforward. All you're doing here is you're creating this basic instructions thing. It does return an int. It doesn't really particularly matter at this stage. It should be probably just void, to be honest. But anyway, what you're doing is you're going into the main procedure. That's where it all begins. You're going to instructions. That, of course, then passes to that. And then you're saying, welcome to the most fun ever. Here are the instructions for playing the game. Then it returns the control to there. Okay? So it calls the instructions function, defines the instructions function, and that's exactly what you get from that. Okay? Right, abstraction. By calling and writing functions, we are in fact practicing abstraction. And that is eliminating the complexity. Once you've written a function, you don't need to really think about it again, or you can actually use it within a particular programming language without knowing exactly how it works. Just as long as it works, that's the main thing that you need to sort of know. You just call the function and think about the big picture without worrying about the tiny details. That should be tiny details. Abstraction is everywhere in our everyday lives, even if you don't sort of know it. If you go into McDonald's, what you will say is, I'd like to have a Big Mac meal, please. I actually don't like McDonald's. I've said this before, because you go in and you point. There's always some, sorry, what do you want? You point at a McChicken sandwich meal, a McFlurry, a Mc everything. Anyway, what you do is you go in and you say, I'd like a Big Mac, please. And that's all fine. And you say that because it eliminates the complexity from your day. A Big Mac meal, which basically means, you don't have to say, I would like 2 burgers, please, and could you possibly put it in a bun as well? I'd like some lettuce and some cheese in there as well with some mayonnaise, and I'd also like a portion of fries, probably supersize everything, because let's face it, McDonald's is incredibly high in calories. And I also want a drink, please. And that just takes all of that complexity away. And that's absolutely brilliant. So, I mean, when you're ordering stuff in restaurants or fast food outlets, that's exactly what it is. When you're ordering things in Costa, my Costa order is always incredibly complicated for some bizarre reason, because I always go in and say, I'll have a regular Americano with some coconut milk in it, please. And can I also have an extra shot of coffee and 2 shots of sugar-free syrup, 1 caramel and 1 vanilla or whatever. I have a Americano mochaccino caramel macchiato latte. Americano mochaccino caramel macchiato latte. I said that once to someone, and then they just looked at me. What would you like today, sir? I have an Americano mochaccino caramel macchiato latte. Anyway, never mind. So it takes the complexity away. You've also seen it when you're ordering drinks. This is a Venom. And a venom is basically a shot of Southern Comfort. Is it shot of Southern Comfort vodka, an entire bottle of Blue Wicked, and some orange juice. So instead of actually going into a bar and saying, not that you can go into bars nowadays, instead of going into a bar and saying, hello, I'd like Southern Comfort vodka, an entire bottle of Blue Wicked, and some orange juice in a glass, please. What you say is, I'll have a venom. And they go away and they make it for you and charge you £25.50 because drinking is expensive nowadays. Thank you, Nicola Sturgeon. Not that I drink. Anyway, functions returning a type. This is us talking about that now. Okay, so we have age here, a sort of age function. So this is a program to take in the year you were born. Okay. And then takes that and converts it. That's absolutely fine. And then asks you what year it is now. Okay. And what it does is it subtracts the year now from the year you were born. Okay. And then it returns that value as an integer. Okay. Brilliant. So it's asking you that. It's quite a detailed sort of example for one method at this time. And that is, how you call it. Okay. So it then says your ages, while getting at the same time simultaneously calling that function to go through all of that functionality there, return that to the main flow of the program, and this is what you sort of get out of it. What year were you born in? 1980 was the time that I wrote this. What year is it now? It was 2018 at that particular point, even though it's 2020, and your age is 38. It's not anymore. I am 40. Yeah, it's a good age to be. I'm quite a handsome guy for 40, I think. And still got all my hair. Not a lot of people do that, yes. And it's I don't even dye it, so it's good. I'm quite happy to be the age I am. Never mind. Using parameters. Okay, so this is a more complex example. Now, you'll notice in the lab today that you've actually got this as an example. So use these slides in conjunction with the labs. I don't want you to go in sort of empty-handed. Okay. So this is using parameters. Now, by that, of course, I mean the doubles here, the doubles here, yep, the doubles here, and the doubles here. Now, you're not actually returning anything here. These are all void. Okay, absolutely fine. So what you're doing is all you're entering is an X. I can do an X. And a Y. Okay, so you're specifying that. Enter an X here. You're converting that to a double. Yep. Enter a Y here. You're taking that in as a string, converting it to a double. And then look at all this. This is great. This is fantastic. So you're putting in, you're entering these parameters to all these different functions. So you get one for sum. You get one for difference. Yep. You get one for product. Whee! And you get one for quotient. Excellent. So you're able to take this, reuse it, these values, and all of those. Okay? And this is what you get. Enter X, enter Y. Okay? So I've put 5 and 5. Okay? So sum is going to be 10. Difference, 0. Product, 5 times 5, 25. Quotient, 5 divided by 5, 1. Easy. So I can't go back on this slide, but that's using parameters without actually returning anything. So you're performing the functionality in here. Okay? Now, no return. This is using parameters with return values. Okay? So this particular, you're putting in the parameters, but you've also got a return value of double, okay? Or return type of double, I should say. Type of double, okay. And you're putting these all in the same thing. So the exact same thing where you're entering an X and a Y, great. Here doing the conversion, and then you're calling all of these. And what you can sort of do there is you can say console.writeLine, and you can call this function within that particular, passing that in as a parameter. You can call that within writeLine. Okay, you're calling it in here. There's your sum. You're still passing in your parameters, which are doubles. There's your difference. okay? Product and quotient, okay? So there you go. That's what they are. You've got to get into, and this is really a design choice here, whether you're wanting to do all of the implementation sort of within, or whether you're wanting to return values, but you should be aware of how to do both, I would say, okay? And that is exactly what you get. Ooh, we'll erase that. No, erase, yes. Excellent. Fantastic. Make it all nice and neat again. So that's what you get again. So exactly the same result, just a different sort of way, design of doing it. So it is in fact your design. All right. So calling the same functions multiple times. Now look at this one as an example. So this is the difference. We're just sort of looking at that. And you can call it in a number of different ways, which is just bloody excellent. That's what they sort of mean by their sort of reusability. So you've got two doubles, sorry, you're declaring three doubles here, okay? So you get x is assigned to 5, y is assigned to 3, and then you're actually saying that z is then the difference of 7 and 2, and you're calling that, yeah, and passing in 7 and 2. 7 and 2, which will of course give you a 5. Yep. So the first result should in fact be 5, yeah? The second result is difference between 7 and 2, so you're passing them in, more or less hardwiring them in. So it's going to give you 5 again, okay? Then the third result is, you can call that again, plus difference, is to show you the variability of these. Okay, so you can return the value, great, 7, 2. You can actually show what that is, you can hardwire them in. And also you can do, you can pass in the variables as well. So you get 5 and 3. So 5 take away 3 would be 2, yeah. In that case. And then you've got z equals 4 plus the difference of x and y. So 4 plus, what is the difference of x and y? 2, which would be 6. I hope. And the fourth result is plus z. I'm not entirely certain. Oh yes, you've assigned that to that. Sorry, so you're outputting 6, I would imagine. So let's make a prediction. Is it 5, 5, 2, 6? 5, 5, 2, and 6. Thank God! If I'd messed up such simplistic arithmetic, I would have had to restart the entire lecture all over again, and we can't have that. It's been 57 minutes. Okay. Functions can return different types, of course. And here we've got an example of a function returning a Boolean value, which is great. Okay, so functions can return any data type. They can even return objects, which we'll get into at a later date. They can return a reference to an object, a pointer to a dynamically allocated object. So really, really quite powerful in that sense. So in this, we've got is x greater than 5, and if it is, then it's returning true to there, and if not, it's returning false. Great. So you can use that to sort of dictate your program control as well. Some good stuff. Right, I'm sorry about this. This seems to be a sort of C++ example and should probably be destroyed forthwith. But anyway, function returning different values. So you've got a string as a sort of question here. You've got a character response, and then we've got a do while as well. And yes, response, I wouldn't necessarily care too much about this. So let's see, what was it actually doing? You've got character response to do cout question y or yes or no, and then you're putting in that particular response in C++. So this is the sort of equivalent of console.readline in C#. So you're putting that in, and then you're actually saying, well, response to is not equal to y, and response to is not equal to no, then it's going to redo this loop. And if it is, return response to. So essentially, you're setting that equal to something. Well, you're not really setting equal to anything. You're sort of trying to either make it yes or no. And if it's any of those, then it won't it will exit the loop by returning that character. Okay. An answer to equals ask you no to. Do you want to save? Okay, so there you go. So it's either yes or no. If there's anything else, it will continue to ask you that. Horrible example, I beg your pardon. Okay, encapsulation. Why we use parameters and return values. We communicate only the information that needs to be exchanged. You don't have to keep track of variables to create within a function as well, and keeps independent code by hiding the details, so it's practicing abstraction. So saves the worry about the details, and the encapsulation sort of hides the details from you. So this is one of the pillars of object-oriented programming. So that's encapsulation, abstraction, inheritance, and polymorphism. I'm not going to write all of them out because it'll take forever. Okay. So this is all to do with software reuse. Writing good functions saves time and energy. You can use these functions in future projects, and you can use entire libraries in future projects. So that's the entire idea of it. Has the following real world benefits. Increases the productivity in any form of company, so the code can be reused and finished quicker. Okay. It also improves quality because the tested code can be used with confidence, so there's no bugs. Okay. Improved performance, and you're saving reinvention of less efficient code. Now, programming languages sort of do that all the time, so you've got to be a wee bit sort of careful there that you're not reinventing the wheel, as we've discussed. Scopes. Functions are examples of the use of scopes. So when you create curly brackets to create blocks, then you create a particular scope. And variables declared in a function are not visible outside it, so they are local variables. Okay, they're local to that function. And as a result, the function is encapsulated. So excellent. Okay. If a variable has not been declared in a nested loop, then the compiler will look up levels of nested scope one at a time to find the variable requested and hopefully get access to it. Okay. It's possible to declare variables with the same names in nested scopes, and it can lead to confusion. So be a bit careful about that. Okay. So variables declared inside for while loops and if and switch statements do not exist outside of the structure, so they are local. Okay, so here's another example in C++. Now, the bad thing that we've sort of done here is we've got an integer j, but you're also outputting j as well, and that's fair enough. But be careful about actually giving these things sort of meaningful names to make sure that you know exactly what's happening. Otherwise, you'll lose track. So here's Admiral Akbar. It's a trap, and I don't know if you can see him because of me. It's a trap, right? Global variables. These are accessible from any point of the program. You may wish to have the number of enemies in existence, the number of enemies killed, that sort of thing. And you can have sort of global constants as well. In both cases, you should limit the use of these because it makes it difficult to keep track of their changing values. They're considered to be bad programming practice, but everyone does it. It should be noted that it's possible to assign default arguments to these parameters as well. Overloading functions. You can have a versatile function that can accept different sets of arguments. So we've discussed that. That was like the add. So that's overloading functions. Okay. So you can have the different numbers and types of parameters, adding 2 parameters, adding 3 parameters, adding doubles, adding integers, whatever. And say you want to write a function that performs a 3D transformation in a set of vertices that took both integer and floating values as an example. Okay, that's for later on down the line. And to create overload functions, you need to write multiple function definitions. And of course, the compiler knows which one to invoke based on the types of parameters and the number of parameters which the definition actually uses. Okay, that's all good. So here's my sort of example of that, and I have decided to call it triple. And In this particular example, we've got a triple which takes string as a parameter and returns a string as a parameter, and all it's really sort of doing there is it's concatenating the string 3 times. So gamer, 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 okay? And then you've got another triple which takes 3 integers as a parameter and returns those integers as parameters. So it's number times 3, okay? So in order to sort of call those in C#, you've got tripling 5 plus triple 5. So that goes, the program flow goes like this to here, ooh, and then triple 5, you're putting in 5, so it goes to here to print out 15. Yep. Then it gives you a new line. So you've got your new line here. These are new lines, by the way, 2 new lines actually. And then the program flow returns to here the triple gamer, and then you're going here to this particular function, you're performing that, and then you're returning the program flow there. I believe I will reiterate that one last time, just for the purposes of clarification, and because I'm enjoying myself writing all of this stuff. But this time, I will do it in yellow, offensive yellow. Okay, so the program flow goes like this. We're going down here. Ooh, careful now, Thomas. To triple 5, yeah, and that's the number 1 because it's taking in an integer, and it knows that because of the actual parameter type. Great. So it outputs that. Yeah. 2 lines, 2 new lines. Great. And then we're going back to here. We're going to this next part in the flow. Then triple gamer. Yeah, so you're going up to the textual one, which takes a string as a parameter, returns the string, and then of course prints that out. Well, actually, this is the part that prints that out. These are the printing outlines, but they call the particular functions within those. Okay, good. Excellent. Right. Inlining functions, I should probably not have this in here, to be perfectly honest. I'm a bit annoyed with myself. This is more to do with C++ than C#, so I think you could probably just ignore that. I don't think C# actually supports inline functions. I'm not sure. But nevertheless, they are sort of things that you should sort of slightly look up. So there is a small performance cost associated with calling a function. You ask the compiler to make a copy of a function every time that is called, and essentially the compiler has the ultimate say as to whether a function is treated like an inline function, so whether it actually sort of replaces that with the code in C++, or whether it doesn't. And C#, I'm not sure it's entirely relevant. But anyway, I've had tremendous fun doing this lecture with the drawing things with smiley face. Okay, so try the lab today. It should be all of those things, and let me know how you get on. And I'll post this on Aula relatively shortly once it sort of compiles or exports to video, which will take a phenomenal amount of time. And I'll put it on YouTube, which will take even longer. So this should be probably posted by, I don't know, it's 9:35 right now. So let's say possibly about 12ish. Okay, right. Bye then.